Hey guys, this lesson is going to be an introduction into trig, and the reason why we have trig is, one of the reasons at least, is you could be given a right triangle, you could be given one of the sides of that triangle and an angle, and from that information, let's say this one's 45 degrees, and from that information be able to solve for any of the different sides that are left over in the triangle. So usually if you would be given sides of a right triangle to solve and asked to solve for another side, you would have two. And so then you could use Pythagorean's theorem and do a squared plus b squared is equal to c squared. But with these problems, they only give you one. So some of what trig does is it allows you to be only given one side of a triangle and an angle, and from there you'll be able to solve for another side. Or something else that it'll do is given two sides of the triangle, you'll be able to solve for the angle values and say what the measure of that angle is going to be. So when we're looking at trig in general, trig is the study of relationships between the sides of triangles and the angles in triangles. So just like I described before, it's going to help us be able to solve for all kinds of different sides and the angles within the triangles. And a lot of what this is built on is similar triangles. And similar triangles are triangles that have angles that are congruent, so angles that measure the same exact value, and sides that are proportional. And if you remember, proportional means fraction. It looks like a fraction. So you end up with a number over another number. And so trig is built upon talking about the sides of the triangle. So they have names for the different sides of the triangle. And the one that you know and are most familiar with are hypotenuse. So when you're looking at a right triangle, the side that is across from the 90-degree angle is always going to be the hypotenuse for every triangle we talk about. But then, well, what do we call these other two sides? And that's where those vocabulary terms come into play. So the first one we have, though, is reference angle. Reference angle is the angle that the problem is about. And in this case, it could be about either angle A or it could be about angle B. It cannot be angle C. All angle C can do for you is tell you that you have a right triangle and that this side right here, AB, is going to be your hypotenuse. So it's the angle that the problem that is about, and the way you know that it'll be about that is the problem will flat out tell you to use it. It'll say angle A. So in this case, angle A. Or it's going to be the only angle labeled. So, or it'll only look like this. Or that'll give you an angle measure. And from there, it determines which sides are opposite and which sides are adjacent to the triangle. And if you remember the conversations that we've had about comparing side lengths, opposite is still going to mean the same exact thing. It is the side that is directly across from the reference angle. So if we look for the side directly across from that reference angle, the opposite side for this triangle with the reference angle A is going to be BC. That's our opposite side. And then the other type of side that they could talk to you about is the adjacent side. And the adjacent side is going to be the side that's next to the reference angle, but it's never ever going to be the hypotenuse. So adjacent's never going to be the hypotenuse, and the opposite side is never going to be the hypotenuse. So if we're looking at the triangle that we have here, our reference angle, I'm going to tell you, is going to be angle A. So this is the 90-degree angle, so that makes that side be the hypotenuse. And adjacent is the side that is next to the reference angle, so right beside. Can't be the hypotenuse, so that means the only angle or the only side that's next to that angle is going to be side AC, so this side is going to be our adjacent side. So in this case, the adjacent side is going to be AC. So from there, from being able to identify your opposite, adjacent, and hypotenuse, they can have you start writing ratios. And these ratios are going to go along with the rules that I'm going to give you in the following lessons. These rules are kind of like operations, kind of like adding tells you, you look at these two groups and put it together. When you're looking at these rules in trig, it says you're going to look at this side over top of that side. So the first example that I've got for you of just starting to look at identifying the sides and setting up the ratio, this one, the first one, they want us to do opposite over hypotenuse for the reference angle, angle A. So the first thing you're going to want to do is identify your reference angle. So our reference angle is going to be angle A. The next thing you're going to want to do after that is to label the sides. So for labeling all the sides, there's angle A. I'm going to go ahead and tell you that this is a right angle. So that means this is our hypotenuse. And then the next one I find after the hypotenuse is I find the one that's opposite. And then the one that's adjacent is what I usually do last. And for this problem, they want opposite over hypotenuse. So if we do that, our opposite value, well, our opposite side is going to be CB over our hypotenuse is going to be CA. And with these, it doesn't matter if you name them CB or BC or BC or CA and AC, they both mean the same thing. And CB is going to have a value of 3 over CA is going to have a value of 5. So if we're looking at with a reference angle of A, our ratio of opposite over hypotenuse is going to be 3 over 5. Looking at the next one, they want us to do adjacent over hypotenuse with the reference angle as A. So the first thing we do is we want to find our reference angle. There's our reference angle right there, angle A, they tell us in the problem. Second thing we want to do is label all the sides. So again, that's our right angle. So that makes this be our hypotenuse. There's our opposite. And then there's our adjacent. And then after you label all your sides, you're going to want to write the ratio. So if we do that, we're looking at the adjacent over our hypotenuse. BA over our hypotenuse is going to be CA. So BA has a value of 4 over hypotenuse. CA is going to be 5. So our ratio of adjacent over hypotenuse is going to be 4/5. And if you look, using the same reference angle, those two are going to be different. And then looking at the last one they gives us our reference angle. First thing we're looking for is reference angle. Reference angle is going to be A. Second thing we want to do is label the sides. So this is our 90-degree angle. Here's our hypotenuse. Then looking for the opposite is the one directly across from the reference angle. And then the adjacent's right there. And for this problem, they want us to do opposite over adjacent. So in this problem, opposite is going to be CB over adjacent is going to be BA. And if we plug in the numbers, CB has a value of 3 over BA has a value of 4. And these are the three big different ratios that we're going to be using and putting rules with. And if you notice, if we're using the same reference angle and the same triangle, those ratios are all going to be different every single time. Well, angle A isn't the only reference angle that we could have in this triangle. We could also have angle C be our reference angle as well. So let's try out these ratios with using angle C as our reference angle. So this one, angle C, is our reference angle. Second thing we want to do is label all the sides. Well, B is still our 90-degree angle, so that makes this side right here be our hypotenuse. And then next I like to find my opposite, and the side opposite is directly across from your reference angle, not touching. And then adjacent is going to be right beside. Now if you notice, the side names have changed, whereas here the hypotenuse is always going to be the same no matter what. It's always going to be directly across from that 90-degree angle. But changing the reference angle changed which side is which, and that's why it's so important to pay close attention to the reference angle that the problem is asking for, and then to be very careful when you label the different sides to say which ones are which. So this one wants us to do opposite over hypotenuse. And the opposite side for this reference angle is going to be BA over the hypotenuse, CA. So the opposite is going to be BA, which is 4 over hypotenuse, 5. Looking at the next one, still using reference angle C. Here's our right angle B, so that makes this one be our hypotenuse. Here's our opposite, and there's our adjacent. So in this problem, they want us to do adjacent over hypotenuse. So the adjacent one in this problem is going to be CB over the hypotenuse is still CA. So CB has a value of 3 over CA is 5. So the ratio for adjacent over hypotenuse is 3/5. Looking at the last one, first thing you want to do is find that reference angle. Reference angle is C. Then label the sides. Sides are going to be hypotenuse, directly across from the 90-degree angle. And then find the opposite side, which is not touching angle C, which is our reference angle for this problem. And then the one right beside is going to be the adjacent. For this problem, they want us to do opposite over adjacent. So our opposite side is BA over adjacent is going to be CB. So BA has a value of 4 over 3. And if you look again, the ratios for this other angle, the other reference angle, they're all going to still be different. So whenever you're doing the 3 different ratios for a triangle, you should get them to all be different. Unless you have a triangle that has 2 of the same sides, but they should all be different.